hello, welcome back. So we will be starting off with partial fractions, and let's say I tell you, okay, I have some number s which is equal to 3 over 4 plus 2 over 5, and if you need to express them as common denominator, what you really do is you argue that okay, so this you can say that we can multiply this by 5 over 5 and we can multiply this by 4 over 4. So what you will get is 3 multiplied with 5 plus 2 multiplied with 4, and you can divide this by 5 multiplied with 4. So both of these are really the same thing. On a similar note, if I say that there's some s which is equal to 2 over x plus 1 plus 3 over x plus 5, what you can also do is do the same thing but now with x's. So 2 multiplied with x plus 5 plus 3 multiplied with x plus 1 divided by x plus 1 multiplied with x plus 5, and this is the same thing, right? Pretty basic algebra. So we know how to go from here to here. We can take common denominator. When we say that we want to split, let's say, this thing into its partial fractions, what we really mean is that we want to go back to this state. Before I start, I should mention that the things that I'm assuming you already know is number one, that you should know how to factorize cubics, right? So for example, if I expand this would give me a quadratic, and if I had a cubic instead, you should already know how to factorize it into its factors, right? And since you would know this, you would also know something like long division, maybe even synthetic division, or comparing coefficient, and any method you like, just that you would know how to factorize cubics. So in this chapter, what we really have, we have four types of fractions that when you split them up, they split up in different ways. So let me start off with a basic example, that is, let's say you have some px plus q, and then in the denominator you have something that when you factorize, it gives you its linear factor. So something like ax plus b, cx plus d, ex plus f, or maybe even more. So when we split this, what we really get is some number over one factor, another number over another factor, another number over another factor, and so on. So here we had linear factors, and when I say we had linear factors, what I really mean is that the when you factorize it, the power of x is 1. So here we have three linear factors. When we split them up, this is the pattern, or this is the structure that you would get. So let me go ahead and try out a question for you. So just from the book, we have that 2x minus 13 is being divided by 2x plus 1 and x minus 3, right? This is already factorized it into its linear factor. So we know that this will equal a over 2x plus 1 multiplied with a over 2x plus 1 plus b over x minus 3. And our aim here is to find a and b. So there are a couple of methods to do this. Actually, let me list down the three methods. This is the first method, and this is at least this is how I know of it. It is known as Coverup method. So what we say is that since these are equal, we can multiply the whole equation by this denominator. So when we multiply this whole thing by this denominator, what we get is, well, on the left hand side this would cancel out, so you would be left with 2x minus 13 is equal to a times x minus 3, because the 2x plus 1 will cancel out, plus b times 2x plus 1. Now in Coverup method, what you really argue is that when we look at this factor, this x minus 3 will be equal to 0 when x is equal to 3. So when x is equal to 3, we have 2 times 3 minus 13 is equal to, well, the reason why we chose 13 is so that this could become 0, and we would only have to deal with one variable, or one unknown rather. So we would get b times, well, 2 times 3 is 6 plus 1. this would be minus 7 equals 7b. In other words, b equals minus 1. Great. So we know one of the unknown, and actually by the same method what we can say is that when x is equal to minus half, well, we would have minus 1 minus 13 is equal to a times minus 3.5 plus, well, 0, because we chose minus half, so that this would become 0. So minus 14 is equal to minus 3.5a. A is equal to 4. In other words, we have reached our goal that this can be this can be splitted into 4 over 2x plus 1 plus minus 1 over x minus 3. Now, of course, one way to check whether your answer is correct or not is simply to go back. So 4 multiplied with x minus 3 minus 2x minus 1 divided by 2x plus 1 multiplied with x minus 3, this should equal 2x minus 13 over 2x plus 1 x minus 3, and we're back. So this answer is correct. So this is the first method, that's called the cover-up method, and the second method is pretty similar to this, and in this you basically take random values of x and then you simultaneously solve. So let me copy this over here. So 2x minus 13 is equal to a times x minus 3 plus b times 2x plus 1. Let's say we take when x is equal to, let's say, 0. So minus 13 is equal to minus 3a plus b. And then, so this is the first equation that we need. The second equation, let's say when x is equal to 1, so you would have 2 minus 13, which is negative 11, is equal to negative 2a plus 3b. This is our second equation. We can simultaneously solve them. So b is equal to minus 13 plus 3a. We can substitute this. So minus 11 is equal to minus 2a minus 39 plus 9a. So we have 28 is equal to 7a, a is equal to 4. So b is equal to minus 13 plus 12, which is minus 1, and we get the same answer. Right, so we took random values of x and then we simultaneously solve. This is the second method. And the third and final method is comparing coefficients. So 2x minus 13 is equal to a times x minus 3 plus b times 2x, what was it? 2x plus 1. So what we can do is we can expand. So right, so 2x minus 13 is equal to ax minus 3a plus 2bx plus b. Right, and so let's group the like terms, that is 2x minus 13 is equal to a plus 2b multiplied with x minus 3a plus b, and hence 2 must equal a plus 2b. I'm just comparing these two, and minus 13 must equal minus 3a plus b. So again, we have two equations, we can simultaneously solve them. This should be a b. So a is equal to 2 minus 2b. So minus 13 should equal minus 6 plus 6b plus b. Minus 7 is equal to 7b. b equals minus 1. Substitute it over here. 2 plus 2, which is 4. Same answer, and this is the third and final method.